Okay, page 2 of your Unit 1 study guide starts with number 5. Science is said to involve a lot of inquiry. What is inquiry? And explain how it relates to this unit. Inquiry is the definition is that it's a diverse way in which scientists study the natural world and propose explanations based on the evidence derived from their work. And that's the NSTA standard definition. All scientists and science-minded people are inquisitive. You ask questions about the world around you, and you don't take your answers at face value. You want evidence to support your information. You kind of want proof about things. So being inquisitive and using scientific inquiry to learn about the world around you is just a way that scientists think. Number 6, where are scientific experiments published? They're published in peer-reviewed journals. All right, so some people will do an experiment and like blog about it or post about it on Facebook. These are not necessarily peer-reviewed or peer-edited journals. There's a level of integrity and ethics that are involved in some of these peer-reviewed journals, even though mistakes can be made. But with the internet, anybody can post anything out there on the internet and on social media and things like that. And you just have to be more careful than ever when you're reading an article about something that you're looking at where it's been published from. Is it being published from a peer-reviewed scientific journal that maintains integrity, or is it somebody's like website that they put together in their basement? You know, so scientific experiments are published in peer-reviewed journals, things that have good reputations like Scientific American, the New England Journal of Medicine. You have to have a lot of creds to get your information published in those, and those are publications that can be trusted. Yeah, like I said, it's really important now more than ever to make sure that the information that you are receiving is coming from reliable sources, not just Wikipedia or something like that, you know, something anybody with the internet can post to. So you have to be careful. 7, scientific papers that are published are often put under scrutiny by the scientific community in order to gain support for their research. Why is this the case instead of first sending the message to the general public? So the first part of the question there is, we already said, the peer-reviewed journals can be reviewed by other scientists, it authenticates your work, and it's conducted by actual experts in the field, okay? So what are some reasons that the scientific community might reject your research? 1, if you fail to follow the scientific method. The scientific community could reject your research if there's an obvious conflict of interest, and we see this more and more with lobbyists flexing their financial and political power. They're kind of getting things through and getting information out to the public that isn't necessarily true. It was just revealed that there was a huge study conducted by Harvard University on sugar. It was paid for by the sugar industry, and these scientists erroneously published information that sugar was safe and that there wasn't necessarily like an upper limit of how many grams of sugar you should have per day. And we know now that this led to a lot of really unhealthy decisions, and sugar is bad for us. So the sugar company and the soda industries pay a lot of money to keep misinformation out there, and you just have to make sure that you're reading things from sources that have integrity, and even then sometimes there's corruption. So again, now more than ever, be careful. But conflicts of interest definitely play a role in being one of the reasons why the scientific community might reject research. And also, if you're unable to reproduce the results. So if I say that I've proven that gravity isn't actually a thing, and millions of people are like, no, gravity is real. If you can't reproduce your results, you're wrong, and you just have to accept that your idea maybe was off. So those are 3 pretty big reasons why the scientific community might reject your research and reject your results. That doesn't mean stop trying. That means you might need to revise your experiment to see if you can come up with a different result, or maybe you're just barking up the wrong tree. Number 8, we're still on page 2. Number 8, what are at least 3 aspects of a good science experiment? I gave you 5 here. You have to have a testable hypothesis. You need to have a control or a constant, something that you're not changing. You're comparing everything else to your control. You're testing one variable at a time. Quantitative data, whenever possible, is our friend. And you need your experiment to be reproducible. Number 9. Can a scientific theory ever be wrong or proven? Explaining your answer is the most important part. So a theory can be supported or refuted, but real scientists tend not to use words like "this is wrong" or "I can prove that," because real scientists remain open-minded, inquisitive, and willing to adjust our beliefs based on new information. So that's an important part of being a scientist. Keeping your mind open, only trusting things that come from validated and supported sources, but also being willing to be flexible in light of new information. That was page